Welcome back, students. Just as a quick review, we have covered the nitrogen cycle, some of the deficiency symptoms, the available forms of nitrogen in soil, ammonium and nitrate, and the eventual fates of both ammonium and nitrate. We have discussed phosphorus and the deficiency symptoms. Part of the phosphorus problem is that it's generally too low to provide for plants. So we have all these management principles to make sure that we don't over or under apply this non-renewable nutrient. Potassium, the third forgotten nutrient. We talked about deficiency symptoms, how it has inorganic forms only, the crazy luxury consumption of plants, and the relation of soil texture and available potassium. We talked about how pH overall influences potassium availability and really the availability of all nutrients. And so based on, now remember that we have 18 plant essential nutrients, but these are the big three that we pay the most attention to. So let's start talking about some management practices and nutrient management. Overall, the goal of this chapter is to talk about how to manage our nutrients and how to create a plan to manage them and the things that we can include in our plan to help protect our crop assets as well as the environment around us. And we're going to talk about some of the fun things we can. So the goals of nutrient management are to provide cost-effective plant production, efficient use and conservation of nutrients, enhancement of soil quality, and how to protect the environment. So the first goal, the cost-effective plant production, ultimately the aim here in agriculture specifically is to increase yield and quality. However, this is going to change depending on how much time you have to put into your operation, as well as how big the operation is or how small it is. So it really depends on the actual system itself. Forestry. Overall, the objectives are to enhance the rate of growth and reduce seedling mortality. In ornamental landscaping, the objectives are completely different. You're looking for produce quality and aesthetically pleasing plants. Ultimately, we generally plant for hardiness, resistance to pests. Color and abundance of blooms is especially important to make it aesthetically pleasing. So again, when we're thinking of creating our nutrient management budget, our goals of our overall plan, it's going to, of course, depend on the aim of the system. Are you growing food for people to consume? Or are you growing trees for a forestry type perspective? Or are you trying to get pretty plants for people's yards? It's going to change your overall nutrient management. So, of course, the next point of nutrient management plan is to conserve our natural resources. We want to recycle nutrients where we can by adding back in plant cuttings to the soil to recycle those nutrients. We want to add in animal manures. We want to look at the overall cycle of things that we're taking out versus what we're putting in so that we conserve our resources instead of wasting them. So ultimately, this all ends up tying into something called soil quality, which is the long-term enhancement of organic matter, of improving soil physical properties, and feeding the microbes. These three components ultimately help to create a soil that has high enough quality to provide nutrients in the long run. We also want to make sure that we're protecting the environment. We don't want too much nitrogen and phosphorus because we've talked about how these are non-point sources of pollution that get into waterways and cause eutrophication. And in watersheds, we're going to see completely different environmental protection needs in a natural watershed versus an agriculturally dominated watershed. And so all this ties into how we nutrients in what's called a nutrient management plan. So when we're creating a nutrient management plan, we have four criteria to consider. We have our residual soil nutrients, with a soil test for phosphorus and potassium and nitrogen. And then we want to calculate how much nitrogen we have in the soil that's going to be released from manure and legumes, which are those really cool plants that partner with a bacteria that takes nitrogen from the atmosphere and puts it into the soil. Our crop nutrient needs are going to be different depending on the crop. We want to make sure we're setting realistic yield goals. We can dream about getting 400 bushels per acre of corn, but in this region, it's really more realistic to go for like 175, and in a really good year, a little over 200 bushels per acre. In poorer soils here, you're going to see about 130 to 150 bushels per acre. All right, and so we need to set realistic yield goals so that we're not destroying the environment. Now, those yields change on the soil type and the location. There's other states that can get higher yields because they have better soils and don't have the water management issues that we have. If phosphorus is a hazard, phosphorus index may be imposed, which is this really cool basic checkbox system where you list all of the amazing environmentally friendly practices that you are utilizing on your farm, and it helps to indicate how well your phosphorus cycle is functioning on the farm. We want to keep our soil and nutrients on site utilizing best management practices, which are the practices to minimize soil and nutrient loss from the land. Things like cover crops, filter strips, etc. So the nutrient flow charts that we create are kind of like a budget. So for example, in a cash to grain farm, we're going to put fertilizer onto the cropland and then we're going to take the crop off. And through those processes, we can calculate how much of our nutrients go into the crops and how much we take off and how much we have left or could potentially be lost to the environment. For a dairy farm, we're going to have nutrients coming in on fertilizer to the cropland, which is fed to the cows, which we recycle their manure back onto the cropland. So we're going to have different ways to calculate potential losses to the environment so we can minimize those. Golf courses are notorious for excessive amounts of fertilizer because they want green, green, greens. All right. They want the perfect grass for the golfers. They pay big money for that. So they utilize a lot of fertilizer and other grass happy measures. And so we really want to make sure that we have really solid nutrient management plans for our fairways. So we're going to talk about some best management practices that are going to help to minimize soil and nutrient losses from the land and help to mitigate any negative environmental impact. We can utilize things like buffer strips and cover crops and conservation tillage and forest stand management to create sustainably developed landscapes across any type of management practice. And these tie into social needs, wants, and desires, consumer awareness, community development, and food safety, as well as environmental concerns for air, land, water, biodiversity, etc. And we care about the economic impact of these things because when we mismanage the societal and environmental sides of this, there is a negative impact on the resources that ultimately drive our economy. So here's some examples of some fantastic best management practices that we can utilize, like riparian and grass buffers, which are basically going to help filter out anything that's coming off of the agriculture practices, because we want to protect our water resources. Utilizing multi-species riparian buffer strips really helps to not only allow for biodiversity of life within these buffer strips, but it's a very complicated filter system for anything coming off of areas where we have cultivated crops. We've got the perennial grasses that act like little fingers, little phalanges grabbing sediments out of flowing water before they reach the riparian area. The bigger shrubs and slow-growing trees and fast-growing trees ultimately provide nutrient uptake systems and water management. Here's a great example of a farm that's using filter strips, a wetland, and windbreaks to help minimize negative impacts to the soils around them, as well as protecting their waterways. You can utilize cover crops. At the end of the growing season when we harvest, if you plant a cover crop, it helps suck up all the extra leftover nutrients and holds them in the cover crop plant tissues until the following spring when a cash crop is planted again. And they help build soil diversity and protect the soil from soil erosion. It's a marvelous thing. Cover crops can provide increased nitrogen availability if they're mixed with a legume, wildlife habitat, erosion control, increases in organic matter, and decreased leaching losses of nutrients. Look at that cute little fox. Conservation tillage is any system that leaves at least 30% residue cover at planting. We have both ridge-tilled soybeans here, which helps slow down water movement because of the raise in the soil. Conservation tillage helps to leave some residue on the surface to tie back in organic matter and protection of that soil over winter months. But the best system is no-till, where we allow the soil to be at its healthiest by minimizing tillage completely. Conservation tillage ultimately ends up in less runoff and better water infiltration into the soil, and it mitigates or completely eliminates unnecessary overflow or runoff, which carries away soil and causes water quality issues. I'm going to skip this table. Forest management is very important because we can lose nutrients by leaching and runoff, erosion of litter, volatilization, and fires, and the goal in most cases is to minimize all of these things. Clear cutting is a very poor way to manage forests. Now, the logging industry is really important, and they have moved away from clear cutting for the most part in the forests within the United States of America. Unfortunately, clear cutting is still a practice in some other countries, and we don't want this to happen because these soils are not made to be bare. They are designed by the vegetation that has lived on them for centuries to have and need a tree-type ecosystem. So a better way to log these would be selective cutting and better management, because clear cutting exposes these steep terrains to extensive erosion, as seen in this photo. Yikes. See, folks, negative consequences of poor forest management result in loss of human resources, infrastructure, and potentially losses of life. Better management is the way. Forest management ideas include selective cutting, protecting the forest floor, and cutting down on dozer use to help minimize soil compaction. Nutrient conservation in forests focuses on nutrient recycling between trees and soil, nutrient recycling within the trees because they translocate nutrients just before leaf fall, and the retention of nutrients in needles for decades. For example, the black spruce needles take forever to break down, and that is their long-term fertilization system. Their needles basically lie at the base of these trunks for decades, slow releasing fertilizer for their as well as their future seedling needs. And so we need to remember to protect these things in these ecosystems because that's a part of their nutrient cycling.